It's go time. Right, Kelvin? Go time. All right, so today, 3 things I want to accomplish. Thing number 1 is I want to get the lesson done and out of the way. Thing number 2 is I've got a bunch of stuff to hand back to you. And thing number 3 is I want to give you some time to work on your homework.
Thank you.
Because Thursday is your test. So Thursday is the day that everything's due. You've got 2 quizzes that you have corrections that are due on Thursday. You've got 3 homework sheets. Some of you haven't even done any of the homework for Unit 2 yet. Okay? So you've got 2 quizzes with corrections. You've got 3 homework sheets. That means that you've got 11 homeworks that you've got to have done before Thursday. Okay? That's a lot, especially if you weren't doing them every day. Okay? All right? So, let's go. Retrieval. So we've got 2 functions, H and G. You can skip here. I'll make you a deal. You can skip part A, but do the rest. Yeah. How do their y-intercepts compare? What kinds of functions are they? And what type of growth does each function have? Okay? And then 3 solves. 3 very quick, easy, one-step solvers down there. Okay? Go for it. So that would be check your work. We can check our work. We want to know if we're right or not. H of x has a y-intercept of 0, 5. G of x has a y-intercept of 0, 5. So how would they compare? They're the same. Yep, exactly. They are the same. Okay? H of x is what kind of a function? Geometric or exponential. It's an exponential function. It would produce a geometric sequence, okay? But it is an exponential function. Okay? G of x is a linear function. It would produce an arithmetic sequence, but it is a linear function. What type of growth does each one have? H of x is by multiplying by 2. G of x is adding 2. Yep. Okay. Sweet. Questions on those top ones? Okay. Solving. What would I do to solve number 2? Minus 6 on both sides. So then that gives me x equals 26. Okay. Justification would be you would put it back in. You would show that you're checking it. 26 plus 6 is 32, and 32 is equal to 32. Okay. Number 3, what would we do? Divide by negative 4 on both sides. X then is equal to negative 13. Negative 13 times negative 4 is positive 52. And positive 52 is equal to positive 52. Number 4. Divide by 7. Not by 7x, just by 7. Okay. So we get x equals negative 5. 7 times negative 5 is negative 35. Okay? All right. So today, you're going to be given a bunch of varying information. It's going to come in multiple different forms. You might have a graph. You might have a story. You might have a table. You might have a recursive formula. You might have something. Okay? Right? And so what we're going to do with that then is we are going to have to determine the equation that best fits that data. And then we can utilize that equation to answer more questions. Okay? So linear functions, we've got we have 3 different kinds. We've got the slope-intercept form, which is that y equals mx plus b form. Okay? We've got the point-slope form, which tells you a point that you go through and the slope. So if you have that rate of change and you got a point that it goes through, that would be the one that you would go to. If you have where it starts and the rate of change, then you would go with slope-intercept form. Okay? Recursive formula isn't going to do much for you because as we learned in Unit 1, that recursive formula only gets you the next term. It doesn't get you like the 50th term without having to perform that operation 50 times. Okay? So recursive formula is probably going to be the last one that you would ever use. If it's exponential, then you only have the explicit form or the recursive form. Okay? So you only have those two in exponential. All right. Let's do this. So our toolboxes are wide open. Okay? Let's start with number 1. In his job as a cashier, Joe makes $500 each month, plus $20 every time he convinces a customer to open up a charge account at the store. Write the equation that describes Joe's monthly income I as a function of n. So right off the start, this is telling us this is going to be I of n equals. Okay, because it told us that our income was I, and it's a function of n. So income based off of the number of accounts Joe solicits. Name the form of the equation you wrote and why you chose to use that form. Okay? So what do we have? Let's interpret what we got in this problem. What do we know? How much does he make each month? For sure he's going to make $500 a month, right? Okay, right? So we know that. He's going to make $500 a month no matter what. Okay, what else do we know? So would that be a plus or a minus? That'd be a plus because he's adding to his income, right? Okay, so somebody give me an equation, I of n equals what? Out of what we just said. Is it linear or is it exponential? Linear, right? Okay. Alright. So would it be easiest to go point slope, slope intercept, or recursive? Okay, why slope intercept? Let's think what we got. Okay, let's go back. Let's think what we got. Okay, what do we need in the slope intercept form? M to B, right? Okay, so the M would be like our rate of change, right? Okay, what's our B value then? Our starting value, yep. Okay, point slope form. What's the M there? That's the slope of point slope form. What's the M? Rate of change again, yep. Okay. And the point here out of the point slope form would be something that it goes, you got a point of, you got some value that you already have at a certain time frame. Okay, so what do we have in this number one? We have a start value. What's our start value? 500. Every month he's going to get 500. Always going to start there, right? So we have a start value. What else do we have? We have the rate of change, right? Okay. So what is the rate of change? 20. Okay, make me an equation. 20n plus 500. Is that linear, exponential, or neither? Linear. Is it continuous, discrete, or neither? Why discrete? No. No. Why is it discrete? It is discrete. Okay? But why is it discrete?
Is that right? Because he can't have half of the customer.
He can't sign up half of a customer. Okay? He only gets that $20 if he signs up one customer. Okay? So it's always jumping 20 every time. It is not continuous here. It is discrete. Okay? What would the domain of this function be? No. Domain would be inputs. You gave me an output. You gave me the range. I would have said it's on the board behind me, but it's not on the board behind me anymore. You guys stared at it for 3 weeks and you didn't memorize it. What's the domain of this function? That would be if it's continuous. Not continuous, it's discrete.
All natural numbers.
Natural numbers? Well, it depends. Can he sign nobody up during the month?
Yeah.
Yes? Okay, so that means we gotta include 0. Which one included zeros? Whole numbers. Yep. Okay? Whole numbers. Alright, let's go to number 2. Write the equation of the line with a slope of -1 through the point -2, 5. Okay? What do we have? We have the slope, okay? And we have the slope and a point, right? Okay, so if we have the slope and a point, which form of our equation should we make? We should make the point slope form, right? If you have a point and a slope, it makes sense to use the point slope form. Yes? Okay, so give me the point slope form of this equation. I'll start you out. Y equals. Side note, what do I not see out on anybody's table? The toolkit. Guess where you're going to find all of these answers? The toolkit. Why wouldn't you use the toolkit if it has everything that you need, Karzek? Too easy, isn't it? What do we got? What do we got? Or we could just use this one right here, too. Yeah? Calvin, give me the point slope form of this one.
The what?
Point slope form. I want that bottom one over there on the board for this scenario number 2. I started you out with y equals.
Y equals -1.
Give me another chance.
Y equals
Follow.
5. Y equals 5.
5. Yep, I like 5.
Or
And then -1 times. Calvin, it's right here. Calvin, right here.
x minus or
Go ahead, say it. I want you to say
I
it.
was gonna say x minus
-2. Do we write minus and -2 though?
No.
No, so what do we write instead?
Plus.
Plus, so it would be x plus 2? Yep, exactly. Okay. What type of function is that? It's linear. Is it continuous, discrete, or neither? It's continuous because it's an equation, yep. The domain of that function. All real numbers, is there any restrictions? No? No restrictions? Okay. Nope, so then it'll be all real numbers. Okay. Go to number 3. Write the equation of a geometric, tap the brakes right off the start. What kind of an equation are we writing? What type? Exponential. Okay. So it means our exponent's got to have where the variable lies. Write the equation of a geometric sequence with a constant ratio of 5 and a first term of -3. You want to use y or function notation? Function notation. What do you want to name your function? F of x. Okay. Equals. negative 3,
times 5.
parentheses 5, x minus 1. Everybody agree with that? Yeah?
Yeah.
Okay. Is that function linear, exponential, or neither?
Exponential.
It's exponential. Now, context. Is it continuous, discrete, or neither? Context. What does context mean? Gotta go back and reread the information again.
Yeah, so continuous.
Why discrete, Todd? Because it's a sequence.
Wait.
Yep. It said write the equation of the geometric sequence. That means it's discrete.
So, wait, if it says sequence, like, no matter what, it's always discrete?
Yep. Because then you're getting the term number. So like whatever term number is has a value. Next term has a value. Okay.
Okay.
Naturals.
Yeah.
Do we agree with naturals?
Yeah.
Because it doesn't include 0.
Yes.
Yep.
The domain's talking about the x values,
Inputs. Yep.
right? Okay, yeah.
Number 4 has a picture of a graph, right? Okay, it's what? It's continuous because it's connected. Yep, I like that. It's linear because it's a line. Yep. Domain, we can do that right away too. All real numbers because it's continuous, right? Is there any restriction on that? No? Okay. All right, now we just got to come up with the equation. Y equals, I heard. Do we agree with negative 3x? It's going up to the right, so that means it's got to be positive. Right? But that's b. Y-intercept is the b. In mx plus b. This one right there. Yep. What we got for a slope? 3/4. Up 3. 1, 2, 3. Run of 1, 2, 3, 4. I would concur with 3/4. 3/4
Minus x.
x
Minus 3.
minus 3.
Wait, is there like restrictions when it's like x is equal to or like greater than, or like, is that like what the restriction is?
That would be like the restriction, yes.
Okay, so like, how do you do those?
Well, we'll get to one.
Okay,
Yep. Yep. The population of the resort town of Java Hot Springs in 2013 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. Write an equation that models the number of people in Java Hot Springs. Okay? With t, we can use x if you want, that's fine. But it's just saying with t equaling the number of years from 2013. So that 2013 was like year 0. Okay? Alright? It is exponential. Why? Because it's got a percent. Yep, so that means it's exponential. Okay? Is it continuous or discrete? Continuous. Yep. Everybody just doesn't move in on the 2nd of April. Which means the domain of the function would be all real numbers. Any restrictions? Nope, not on this one yet. Okay? Alright, now we just got to come up with the equation. Want y equals or function notation? Function notation, okay. What do we want to go with our name? Oh, let's go P of T. Population, man. Alright, P of T. You could still do F, it's fine. You just erased it. That's fine. Either way. Okay, what do we got? P of T equals 35,000 times. Are we increasing population or are we decreasing population? Increasing. So what's my R value then? 1.024?
Yes.
To what? Do we agree with T minus 1? Just T, right? Because it was saying that T is the number of years from 2013, so that means 2013 was year 0. Okay? Sorry, I was getting chased there. See, I'm getting chased by a fly. Getting chased by a fly? Could be. I could be the predator in this case. Yeah. Like in the wild, not.
What?
What are we?
I just said already, like as we're moving on.
Oh, got it. Oh, got it.
All I heard is we're chasing a fly.
Well, no, I'm being chased by a fly.
Oh.
Oh.
I don't know, I think you're cheap. The flies in the judgment zone.
What was that? I'm the prey of the fly. Okay. They're vicious. When they bite nasty. Like they don't play clean. No.
They don't come to play.
No, exactly. Okay. Jessica. I like that name. Jessica. Jessica. It's like Jessica but with a Y.
Yes.
Yes. Jessica. Science fair project involved growing some seeds to see what fertilizers made the seeds grow fastest. One idea she had was using an energy drink to fertilize the plant. Ew. Ugh. She thought that if energy drinks made people perky, energy drinks might have the same effect on plants. This is the data that shows the growth of the seed each week of the project. Okay? Write the equation that models the growth of the plant over time. And the name of the equation you wrote and why you chose that for. Okay, well, we've been talking about that the whole time. Okay. So, what do we think it is? Let's go down to D here first. Is it linear, exponential, or neither? Why linear?
No.
Plus 1.2 every single time?
Oh my god.
1.7 plus 1.2 is 2.9. 2.9 plus 1.2 is 4.1.
Yeah.
4.1 plus 1.2 is 5.3. Yep, so that makes it linear. Okay?
Continuous.
Exactly. It doesn't get to like on Tuesday of each week. It doesn't grow that 1.2 inch. Okay, so it would be continuous. Okay. Domain. All real numbers
With an exception.
with a restriction. What's my restriction?
That I do not know yet.
Okay, we'll come back to it. Let's come up with our equation first. Okay, what equation do we want to make? F of x. Okay. You want to go H or F? F. Okay, F of x. That's fine. Equals what? Okay.
1.7.
Oh, what?
No. I want her to finish. Go with it, because I know exactly what you want to say. Go with it. 1.2x.
2x plus.
Oh, I thought you had it.
No, I just was saying like the first part. Plus 1.5.
Not 1.5.
0.5.
0.5. Yep. Okay.
Thank you, Ty.
Now, most of you probably would have put down this. Most of you probably would have put down 1.7 plus 1.2 times x minus 1. Right?
Yeah.
Okay? What's the difference between anonymized and that one? It's just simplified, right? Yeah. Okay? Alright? Now, back to you. Restrictions.
Back to me.
You said there was going to be a restriction.
Yeah.
Okay? Now that we know what our variable is, we could say, comma, x, what? What about x?
Is equal to or greater.
So greater than or equal to?
1.2.
No. No.
0.5.
Say it louder, Ty.
0.
Why? 0.
Can't be like negative height.
Not negative height. What is x?
Oh,
Negative week.
It's weeks. It can't go back in time. Okay? The plant isn't going to grow backwards in time. Okay?
Yeah.
No. Because once you plant it, it starts. It's not like, okay, here I'm at -1 weeks and I'm going to get planted. Now I'm at -1 day and I'm going to get planted. Oh, I got planted, now I can start. Okay, you know what I mean? It's not like I can do any of that before. Okay?
Wait, so like, is this gonna be with any like word problem? Is there like a restriction?
There could be, there's a possibility. So far we haven't had a restriction, we've had a couple word problems.
Yeah.
Right? But yes, with word problems, you have got to read the context of the problem and stuff. So like when we were filling a pool, we had a couple of those type of problems. You know what I mean? So we'd have to figure out how long it takes for the pool to be full, because then that would be the restriction. So it would be from 0 to, let's say, 212 minutes.
Okay, so it like depends on like.
Yep.
Okay.
Yep, it depends on what the problem is saying. Yep. And you gotta be able to decipher. Do we want a graph?
No. Not really.
Not really?
Not really.
Okay. Alright, I'm okay with it. I'm okay with it. Do we want to go through last night's homework?
No.
Yes.
No.
Yes? You got some questions? Camp, there's people that have questions. So yes, we are going to go through it. Okay? You probably haven't even done it yet, so you did it. Oh, okay. Alright, so what do we got? What questions, Brady, did you have? I get it. What was that? So we've got the slope and a point, right? Okay. So we could use the point slope form, yes? Okay. If I use the point slope form, then that's going to be y equals 11, because that's my y value, right? Plus -5, so I'm just going to write -5 times x minus 4. With me on that? Okay, so that's the point slope form. But then yesterday I said I wanted all of those in y equals mx plus c form, because then they're all the same. Right? Okay? So then this would be 11 minus 5x plus 20. Right? If I distribute. So then that would give me y equals -5x plus 31. Okay? Now, on Thursday's test, there's going to be a couple of questions where it's going to tell you, like, just give it to us in point slope form. So you still got to know how to use that one. And then there's going to be other ones where it says, give it to us in slope intercept form. So you got to know how to go from one to the other. Okay? Other questions on 2.10? Okay, let's look at 2.11 then, see what we're dealing with here today. So on the front side of 2.11, what you're doing here is you're finding what type of growth it is here. So like this one would be Okay, so we're adding. Here we're multiplying. What kind of sequence is this one? It's arithmetic because it's linear, right? Going to put linear for the type of growth too. This one, exponential because it's, so it'd be geometric because it's exponential, and so on and so forth. With your table of values, I want at least 3 values in there. Okay? All right? Rate of change, just a small little graph, doesn't have to be very accurate. You'll be able to tell which one, and the y-intercepts for each one. Okay? Then finding some y-intercepts. Love it. Sets. So sets is kind of like what we were doing today. Okay? So you're writing the equation based off of what you have in the problem. Okay? In number 5, I found this a little confusing because it says find the number of rectangles created with 5 folds, but it's asking you for the equation. It's not asking you for the fact that there are 32 rectangles created with a fold. Okay? Right? Punching bag. Scott with a workout plan. All good. Okay? Then you got 2 graphs. And 6 solves. Okay? All right.